Hello everyone, welcome to another machine learning project series video. Today we're gonna be building a big Mart sales prediction model. So let's start. So here the steps are coming that I'll gonna follow to build that machine learning model. First, the data import will come. Here I'll gonna import the data set. After that I'll gonna be moving to EDA process, also known as exploratory data analysis. For EDA, here I'll gonna be learning about the data, what the data is actually expressing to us, and after that we're gonna do feature extraction. In this EDF process, we're gonna check the data set is properly corrected or not. Like, is there any null value, or all the data that is given on the data set is properly visible or not. After that, on feature extraction, we're gonna extract some features that is needed to build our model properly. After that, with that features, I'm gonna be moving to pre-processing. Here pre-processing is not the mandatory section. If it is needed, then I'm gonna process the data using the pre-processing method that is available on Python. After that, I'm gonna be moving to model building process. Here I, from all those steps that I'm gonna follow, I'll be having all those data that is that will be needed to feed that model, and using those data I'm gonna be building that model here. And after that I'm gonna move on model comparison. Here model comparison is not mandatory. Maybe I'll do, maybe I'll not do, because most of our previous video on logistic regression or categorical dataset I did already model comparison. So I think for this one is not mandatory here. So now we have the outcomes, like prediction. Like for step one, what I can do, what I'll do over here, I'll simply measure the R square error or R square score over here to see the percentage that are coming for accuracy. And for step two, I'm gonna be plotting the predicted or actual price, the values that are coming to the through the predicted lines and through the actual price. And on the next, we have the models that can be used on a regression data set. Like our values will be continuous for price. So it will be like on previous we mostly use the logistic regression and all other categorical data set, but here we can't use those. We will use the linear regression, decision tree, KNN, super vector machine, and XGBoost and GBMS, also known as gradient boosting machines. Here the difference is that, like for KNN SBM, we're gonna use not SBC classification one. We have to use the SVM regressor one. Also here are XGBoost also there. We will use the regression model here mostly. So right now let's jump into our Jupyter notebook. So to build this model, we're gonna use those steps like data import, EDA, feature extraction, and model building. We can also do pre-processing here. If pre-processing is needed, then I'll gonna do. So let's jump into our Jupyter notebook. On our Jupyter notebook, first what I did, I simply imported all the necessary libraries that is needed to build this model, like NumPy, Pandas, Matplotlib, Seaborn, and from sklearn pre-processing, I simply imported a label encoder that we will gonna use on the next we're gonna see how we're gonna use. And from the sklearn model selection, I simply imported train test split, and from XGBoost I imported XGB regressor, and from sklearn I simply imported the metrics to actually measure the metrics like accuracy of our ML model. So what I did over here, I initialize our data set as a data using pd.read_csv file, and I gave the path over here train.csv. I'm gonna simply run this one, and from here what I can do, I can simply call data dot head over here. If I simply run the data head, I can see that first 5 rows are coming and all the columns are coming respectively. So what I can do over here, I can see what I can see over here, like there are many individual columns over here, like item identifier, item weight, item fat content. Also we have item MRP, max retail price. Also we have outlet establish here on also, and also we have other columns like outlet size. We have item outlet sales over here. From that, what I can do over next, we can simply go to our EDA process to learn about this data. So first what I can do over, I'm gonna simply call data dot shape over here. If I press data dot shape, we can see 8523 entries are coming, those are rows, and 12 columns are coming over here. Next what I can do, I can simply use the data dot head over here, sorry, data dot info over here, and info function over here. If we run this function, we can see like there are many details coming from the data set. Like we have 12 columns over here, and data type is classified into three forms like floating, integer, and object type. And all are non-null values, and here data type is coming over here, and all the entries coming and the columns are here. And for the all the columns are coming as a list over here. So what I can do after, now we can simply check data dot describe over here. So what for data dot describe, all columns is not there because many individual columns have object, seven columns have object, and only five columns are in numerical form, which is float and integer. Only numerical form columns will come over here because the describe function only picks the numerical columns and simply calculate those. Like here the minimum values we can see, like establish here minimum, it is in 1985 is coming, means the first outlet came 19 or 1985. And we can also see the item weight over here, 4.5 kg is coming, and item visibility is coming 0 minimum, and item MRP max retail price is coming over here 31.29. So the price is starting with this range, and outlet sales also coming, and 25% values, 50% values, 75% values are there, and maximum values are also there, like item MRP, item visibility, and item weights are coming. And last established happened on 2009. And we can see that item outlet sales, highest sales is this one, like 13,086.96, that is coming over here. So using this describe function, we learned many things about our data set. After that, what I can do over here, I can simply use the data. I can check is there any null value or not. So as you can see, for first five and last five rows over here, all variables are coming as false. So there is no null value for the first five rows and last five rows. But I don't know is any between there is any null value or not. So I'm gonna simply call the sum function over here. If I call sum function over here, I can see for all the individual columns, the values are coming, like the outlet size, like there are coming to 2410 null values in there, and 1463 null values are there. And after that, all those as coming as 000, means there is no null value over here. So what I can do over here, I can also pick some function, another sum function over here. If I pick some function, total 3008,733 null values are there. Now what I can do, I can simply remove those entries. So what I can do over here, I can simply pick data dot drop, and if I place data dot is okay, like there is a proper function over here that come for dropping null values. I can use drop. It will drop all the null values. I'm gonna use data to initialize on our data set. Let's check it is running or not. So simply verify this one. Like I'm gonna check is now again, sorry, is there any null value or not. I'm gonna pick some function again. If we see right now it is coming as 000, means there is no null value, or our null value is dropped over here. I'm gonna simply sum it up. Yeah, it is coming as 0. They are like there are no null values. So if I check data dot shape over here, I need to check the data is like properly in shape or not, because I don't need any overfitting issues on the next. Like we have 4650 rows over there, that is enough for our ML model. So what I can do over here, I can simply do other analysis, like I can check the mean. Now other parameters also, like we can take describe again, as we dropped our null values over here. So right now the minimum, if we check, 1987 is coming, and previously all those data has been dropped because of null values, and maximum is coming 2009, and established year is there, and also other value is there, item weight minimum is 4.5 kg, and MRP also 31.49 is coming over here. And many values are changed because of dropping all those null values. Now what I can do over here, I can simply plot many distribution, distribution to check our density of the data set for particular columns. So what I gonna do, I gonna pick a plt dot figure over here, and for fixed size I'm gonna give I'm gonna first get fixed size over here. I'm gonna give fixed size as 6 and 6, 6 comma 6. For here I'm gonna pick SNS seaborn displot distribution plot over here, and I'm gonna use data. From data I'm gonna pick I can simply pick item weight over here to check item weight distribution, and after that I'm gonna use plt dot show function over here. So if I run this up, now the distribution is coming. Okay, I need to first give SNS. Okay. I think everything is done over here. It's simply coming. So as you can see here, okay, counts are coming. I need this plot over here. It should count. It should come density. But it is coming as count over here. Okay, I need to check once. I need to simply use this data over here. Okay, if we see, okay, wait, DIHT over here, I simply missed this one. So now the distribution is coming over here, like density and item weight. For item weight, as you can see, between 6 to 10 maybe, it is coming as a higher value, density is more. On our data set we have more density on weight from range between 6 to 10, and after that the after 20 it is coming as low. It means the density becoming no low because of we have low number of data that are having upper than 20 kg, and also we have here on 5 kg also it is low over here. So after that what we can check from our data set, we can check we can use the same distribution plot, and we can check over here item visibility also we can check. We check item visibility, density also coming is over here. It is coming as a pointer, as a floating number. So for here from maybe 0.4 or something 0.5 between, it is coming the higher. The more number increasing, it increasing by range. The density is going on downside, like it is decreasing, as you can see. Now what I can do over here, I can simply copy this over again and paste it over here. We can simply check other also, item MRP also we can check over here. I'm gonna check item MRP and let's run it. So for MRP I can check it is coming 0 to 300, it is coming. So for there is many increasing and decreasing between happening over here on the density. So if I see from 100 to something 100, maybe 120 or 30, it has the highest number of density. And if we check from 150 to 200, it is moderately high. And if we check, the lowest one is coming from 200 to 250, and after that maybe 60 70, a line is coming too much low, means density is low. It is a low number of values are there, and from a starting point 50 or 0 to a 40, it is maybe starting. the MRP is studying over here. So like those MRP are also coming as in high increasing number. So like we check the MRP also. Now what we can check, let's copy this one again. We can check other also, like what we can check over here, we can check outlet establish here. No, we'll check outlet like item outlet sales over here. If we check this one, I can simply paste here, run this. Like if we check the sales over here, like for 2000 to like 2000 to 4000, most of the outlet sales is between these sales 2000 and 4000, like more density over here. But it is decreasing, the highest the sales is going. So more number of outlet is sorry, more number of outlet have low highest sale. Most of the sale is happening between like from 0 to range over 4000. But some outlet got like high sale over here, like 6000, 8000, or maybe 10,000. So after that what we can check over here, we can check the establish outlet establish here also. We can check for here, I think it's not floating, it's an integer form. We can check also using a like count plot here. So I'm gonna simply pick count plot from figure. From figure I'm gonna simply pick the fixed size. I'm gonna use the fixed size over here. I'm gonna give the fixed size, and after that I'm gonna use SNS count plot. I'm gonna use x, and for x I'm gonna use outlet establish here, and gonna use data, and I'm gonna pick data as I initialize data as data over here, and I'm gonna use a plt.show function over here. And like as you can see, like more number of established here that is happened on 1987, more number of count values are here. Like most of the count values, as you can see, it's nearby coming. So like if we think about the outlet that is established over the year, like from 1987 to 2009, the range is coming, same number of counts are coming. So like for each number of year or each number of individual range here, we have the same established uh, outlet over here for the Mart. So I think this count plot is also done. So after that what we can check, I'm gonna use data dot head over it, sorry, data dot head. We can check again. So for here what I can do over here, what I can check again, establish here we also checked, MRP we checked, location we didn't check. We can I think most of them are checked over here. We can check also item fat content. I just copy this up, simply use those count plot again, because it is on categorical form. It's gonna work. So I'm gonna paste it over here and run it again. As you can see, for item fat content, if we can check, like for low fat more items are coming, and for regular it is coming on moderate, and low fat like it is coming on low position, and a regular is coming also on similar. And like okay, like there are some duplicate values, I think we need to process. After that I'm gonna check on last moment, like on item type we can also check like item types over here, like how many item types are getting on the data set. I'm gonna paste this up, and I'm gonna pick this item type. I'm gonna simply copy this up and paste over here. If we paste this, as you can see, for item type, like many items are there. I can change this fixed size, like I can use 30 and 6 over here, height and width. So for here like many items are there. More item we are. Let's zoom a little bit. Okay, zoom is not working over here. So like if we check the snack foods are snack food and fruit and vegetable are coming as the higher count. Most of the outlets have this product more. Household also coming, and also frozen foods also coming. And the lowest value like breakfast item is coming as lower item, and bread, seafood also coming. Like other like some other products are there that is not like revealed. Those also coming as low portion. So after that, what you can also check from here, we can simply check the outlet size over here. So copy this up and paste over here. I will gonna copy this photo again and gonna simply paste this. Sorry, and I'm gonna replace this one. Use this and replace this one. If you check the outlet size, like the outlet size that are high like big size are coming as a low number, and the medium size is coming as higher. Also small size outlet is coming as higher number. So like this means the more number of outlet is small and medium, and like there are there are minimal number of outlets that have higher size, bigger size. Now I think up to now our EDA process is done. We learned many things from our data set. We revealed many data from our data set. What I can do, I'm gonna use now data processing. As I told for here, like item fat content. What is yeah, like many values are repeating over here. Like for reg, it means regular. Low fat is there. So I'm gonna use this one. I need to pre-process this one for proper proper prediction. So I'm gonna use data dot replace over here, and for replace, what I can do over here, I gonna simply copy this one. I need this column. Okay, and from here I want to change like low fat. Mm, let's copy this up. I'm gonna take a new cell over here. Sorry, insert. Run this up. Now it is visible. Like I'm gonna replace from low fat to this capital letter low fat. So I'm gonna copy this one from the data set and paste over here. Okay, sorry. And what I can do after that, I can pick LF, also means low fat. It's also is also there. So I'm gonna pick low fat as LF. I'm gonna simply process that and pick from our data set. And after that, what I can do here is regular. It also means regular. So I can pick the same thing from our data set and I replace this one. So from this up to now, I think everything is done. What I can do over here, I'll use in place as I'm using the columns, and I will hit true. So if I run this one, yeah, it's working. Now if I pick data the dot item fat content, this one, and if I pick value, let's go counts over here. What I can do, okay, like sorry, from here we can also do this. Now see, like I already processed this data and it is now classified into three terms like low fat, regular, and higher. On capital letter is written like capital letter L O fat. And now our data is totally fine. Over here we can use this one. Now after that, what I'll do over here, I'll call our dataset again and hit data.head over here. Now if I hit data.head, as you can see, like many individuals column, like I'm gonna use data.info, that's better. Like see from data.info, as you can see, like a floating integer and object are coming, 7 objects are coming. So from object, we have those objects, those are not in numerical form, those are on like floating and integer form. So like for those object, we need to convert into integer or floating number to feed into our machine learning model. So for that I need to use the data processing over here. So here for here converting those into numerical form, I'll use the encoder. And for encoder I'll pick a level. I'll call the level encoder function over here. I think I previously initialized this one dataset. Yes, this level encoder over here. Simply copy this. I'll simply copy this one. Yes, same to same. And I'll gonna hit it and run it over here. So for here we need to transform all those like columns. So what I'm gonna do, I'm gonna simply pick this code I have written previously, and I'm gonna paste it over here. The reason I am not writing, because it's a little bit big, it will take time. So for reduction of time I am doing this. So for what I did over here, for each column that is in object form, like 1 2 3 4 5 6 7 columns over here, I am using the encoder, and using that encoder function I am hitting that column, that individual column, like encoder dot feed transform. I am transforming this that column using level encoder. So what it will do, it will gonna pick those individual columns that are in object form and convert into numerical form. So let's run it. Okay, like sorry, I need to process data and data. I am simply replacing all those big mart data into data. Previously I used our data set as big mart data initialized, but this time I am doing using data. uh, okay, I need to change those also. Data, and I will use this data also. And change other. Let's run it. Yeah, it's working. So now let's check our data.head over here. So as you can see, all those are coming in numerical form. All those are converted into, from object form, it's converted into numerical form. Now if we check our data info over here again, we can see all those are coming as integer format and floating format. It already converted into numerical form. So right now it is this data is capable to feed into our machine learning model. So what I can do over here, I can now go to splitting the data set. For splitting the data set, what I can do, I can pick x over here. So for x I'll pick data, and I can use the drop over here. And for here I can do, for columns, sorry, mm, yeah, like for columns, what I'll do, I'm gonna use the sales over here. I'm gonna simply drop it. So for here, what I am doing, simply I'm dropping this one, like item outlet sales for X, and for Y I'm gonna pick all other columns. So for machine learning model, it will gonna feed all those data like from 0 to 10, and after that it will gonna predict the 11th column, like items outlet sales column, and it will gonna check the sales price prediction. And what I can do over here, I can use the axis as one. Uh, because I am using the columns over here. And for here y, I'm gonna take data, and I'm gonna simply take this item outlet sales only. I'm gonna paste it over here, simply run it. So if I print x over here and run it, see all other columns came without the price without the price outlet price one. Sorry, I'm gonna use print again. Now I'm gonna hit Y over here. So for here only the output sorry outlet sales are coming. Only that individual column is coming over here. We're gonna predict this column only. So what I can do here, I can simply divide this dataset into train, test, and display it over here. For this one, I'm gonna use X train and X test and Y train and Y test over here. And here, what I'm gonna do, I simply wrote here 10 test state. I'm gonna simply copy this one and paste it over here. And here I'm gonna feed X and Y over here. And here I'm gonna take a test size as 0.2 over here, and for random state I'm gonna use 2 over here. Now let's run it. Now for here, what I can do over here, I can check using print. I'll use X train shape over here, and also we can check X test dot shape. Okay, if I check over here, we can see our data set is perfectly divided. Now I can now jump into our machine learning model, building machine learning model process. Building process. So for here, what I can do, I'll call the regressor function over here, taking regressor, and I'm gonna use this XGBoost. It is a boosting technique. From a XG boosting technique, I imported the XG XGB regressor. So I'm gonna simply copy this one and come over here. I can paste here and simply call it as a function, and let's run it over here. What I can do over here, I can use a regressor, and I'll take the fit function, and using fit function I can use X train and Y train, and let's run it. Okay, it is running properly. All the values and properties came. Now what I can do over here, I can check the prediction. For prediction, what I can do data, use take a data underscore prediction, and I call a regressor, and I will call a predict, and for predict I'll call extend over here. Now let's run it. So what I can do over here, I'll gonna check R2 score, also R square value over here. So I'll gonna take R2 train over here, and I'm gonna use metrics. From metrics I'm gonna simply pick R2 score. Okay, it will be underscore score, and from score what I can do, I can use function and use the Y train over here, and this one data prediction. Let's run it. After that I'm gonna use the print function to print like R square error, and for here I'm gonna use R2 train over here. So let's now print this. Like there is a syntax error coming. Okay, sorry, yeah, like it is coming around 90%. So we got a good accuracy value, like 90% is coming for our R square error. It means our model is around 90% accurate. So as you can see, our model building process is done, and we also measured our R2 score, accuracy score coming as 90%, which is a good value. I think up to now it is the model building process is done. So thank you for being for such a long time.